15.2 is 2A relative frequency tables. Comparisons of different relative frequencies in data can reveal associations or trends that the frequencies themselves might not show. The table below compares the weights of corn chips found in two different sizes of bags of 3 brands. So the table title is the amount of chips in 24-ounce bags. So we have brands A, B, and C, and there were a total of 179 bags of chips in this survey here. So brand A were 62 bags, brand B were 79 bags, and then brand C was 38 bags. Okay, so they were counting whether they had bags with less than 24 ounces of chips, bags with more than 24 ounces of chips, and bags with exactly. So they measured these bags of chips and found out how many of each type were in there, okay? So the MRF is the marginal relative frequency. So put that here. That's what we're going to talk about first here. Marginal relative frequency, which is abbreviated as MRF, is the fraction that compares the sum of all frequencies in one row or column to the total of all frequencies in the row or column. So an example would be the marginal relative frequency of all of brand A's samples. So the total of brand A is 62, right, out of the total of all the chips, which is 179. And if we made that a percentage, it's about, so 32 divided by 179 is 34, and 0.6%. Okay, so you are comparing the sum of all frequencies in one row or column, so we did brand A, to the total of the entire chart, the graph there, okay? The other one is conditional relative frequency, and it's abbreviated CRF, conditional relative frequency. Okay, and that is the fraction that compares one frequency in a row or column to the total of all factors in that row or column. So if we were looking to find the conditional relative frequency of brand A samples with less than 24 ounces of chips, so we're taking less than 24 ounces, which would be 12, and we're still doing brand A, right? And we're comparing it to the total of that row or column, which would be 62, excuse me. So 12 out of 62, which is about 19%. 12 divided by 62. Let me double check on that one. I rounded the first one to the 10th, so I should probably on this one. 12 divided by 62. We could say 19.4 if we wanted to round to the nearest tenth. If we round to the nearest tenth of a percent, if we rounded to the whole, it'd be 19, depending on what your directions say. Okay? So we're going to solve and show our work on these problems. Which brand may have quality control problems when it comes to selling the advertised amount of chips in its 24-ounce bag? Use the marginal relative frequency and or the conditional relative frequency values to support your answers. Okay, so let's do brand A. And we want to find those that have more or less than 24 ounces, right? More or less, because the ones that are exactly are the ones that are okay. So we want more or less than 24 ounces. So in our table, in this table up here, we would have the 12 and the 10. So 10 have more, right? And 12 have less. And then our total is 64. That's our conditional relative frequency, right? So 22 divided by 62, if we go to the nearest whole, would be about 35%. Okay? And then if we look at brand B, we could do the same thing. Those that have more or less than 24 ounces. So if you look back at the chart, looking at brand B, you have 9 and 15, right? So if you take 9 plus 15 out of the total for brand B, you would have 79. So you're going to take 24 divided by 79. And if you round to the nearest whole percent, that's about 30%. Okay. Going on to brand C. And we're again going to look at those that have more or less than 24 ounces because those do not meet the standard of the 24. And then you go back and look at your chart. 7 and 6, right? 7 plus 6 out of the total of 38 that were tested. So 13 divided by 38 is about 34%. So they're all very similar, but the one that has the biggest problem would be brand A, right? They're the one that is off the most. So of the three, which brand may have quality control problems? I would say brand A. They all kind of have major issues, but A has the biggest issue of 35%. Okay, if we look at the next one, which brand has the greatest CRF for less than the advertised weight of chips? And what does this indicate about the accuracy of the label? So remember, we're going to be looking at the frequency to the total of that row or column. So if we look at brand A, if we go back up to our chart, okay, brand A for less than the advertised would be 12, right? Out of the total of 62. That's what we're looking at, less than. So 12 out of the 62, which is about, if we round to the nearest whole percent, 19%. Brand B, again, we're doing less than. So in the same column here, 9 out of 79. Find your percentage. Round to the nearest whole percent is 11%. And then brand C. The total for less than 12 ounces was 7 out of the total of brand C, which is 38 bags total. So 7 had less than 24 ounces out of the 38 that were tested from brand C, which is about 18%. Okay, so the question asks, which brand has the greatest CRF for less than the advertised weight? Well, again, that's going to be brand A because it's 19%, right? So brand A has the greatest percentage of samples that contain less than 24 ounces. Okay, we'll go on to your guided practice. So your guided practice is going to be found on page 462. Okay. It says, in a class survey, students were asked to choose their favorite vacation destination. The results are displayed by gender in a two-way frequency table. Okay, so it says in the class survey, we've got 7 girls preferred the seashore, 3 mountains and 2 other. So we got to finish filling this out. So the total then for girls would be 7 plus 3 plus 2, or 12. And then it says the boys, 5 preferred the seashore, 2 mountains, and 6 other. So 5 plus 2 plus 6 would give you 13. Now we can add the other way of the seashore of the children. 5 plus 7, or 12 of the total kids preferred the seashore. 5 the mountains, and 8 other. We can add up either our column or our rows to get a total of 25 students surveyed. Okay? So now we're going to go ahead and do the bottom one where we have gender, and we're going to figure out the percentage. Okay? So it says seashore was 7, right? Out of the 25, and they want the relative frequency as a decimal, so 7 divided by 25. I'm actually not, it's going to squish it in there, but that's what you're putting in that table. In this spot here, you're putting the 7 out of the total. 7 out of 25, which is 0.28, okay? So that's how you're doing them. And probably write it down so you know how to show your work. Then mountains would be 3 out of 25, right? So take 3 divided by 25. In this spot, you're taking 3 divided by 25. And that's 0.12. 12 hundredths. The other would be 2 divided by 25. If you look at your table, we're dividing all these by 25, which is 0.08. And you can either add those up, or you can take 12 divided by 25, right? Because it's already totaled here. Or you could add up all your percentages here, which is 48 hundredths. Do the same thing with the boys. 5 divided by 25 is 2 tenths. 2 divided by 25 is 8 hundredths. 6 divided by 25 is 24 hundredths. And 13 divided by 25 is 52 hundredths. Now all we have left is the totals, which we could add up or we could still divide them. 28 hundredths plus 20 hundredths is 48 hundredths. Or you could have taken 12 divided by 25, either way. 5 divided by 25, or if I add them up, I get 2 tenths or 20 hundredths, does not matter to me which way you write it. 8 out of 25 is 32 hundredths. And then your total is going to be 1 whole. Okay, so it says to use the table to find the joint relative frequency of students surveyed who are boys and who prefer vacationing in the mountains. Okay, so we got boys who prefer vacationing in the mountains, which is 0.08 or 8%. A decimal or a fraction is fine. Use the table to find the marginal relative frequency of students surveyed who prefer vacationing at the seashore. Okay, so here we have vacationing at the seashore, a total of 48 hundredths or 48%. And this one we're comparing 1 out of the total, which is 48%. G says, find the conditional relative frequency that the student surveyed prefers vacationing in the mountains, given that the student is a girl. Interpret the results. Okay, so if we look under mountains, okay, and girls, so we have, and I'm going to use this one up here, 3 girls, right, that prefer mountains out of a total of 12 girls. So 3 out of 12 is about, well, it's exactly 25 hundredths or 25%. And the results mean, if we look at that, if we compare it to boys, it's less, right? 2 out of 13. So what we could say is girls are more likely than boys to prefer the mountains. Girls are more likely than boys to prefer the mountains. And the last question says, how can you use the two-way frequency table to learn more about this data? Okay, we can use them to find joint relative frequencies, the marginal relative frequencies, and the conditional. So you can find joint relative frequencies, marginal relative frequencies, conditional relative frequencies, and you can look for associations and possible. How are they associated? How are they related with one another?